So how do we get from believing everything was made out of fire to what we know today? Well, to begin, let's go back to 350 BC in ancient Greece, where Democritus proposed the first atomic theory. He said, once an object is cut up enough times, it will eventually reach a point where it becomes indivisible. He called this the atom. Every object was made out of different atoms. For example, cheese was made out of tiny cheese atoms, and leaves were made out of tiny leaf atoms. Around the same time, Aristotle came up with his own ideas. His theory was similar to Heraclitus's, where everything was made out of the four elements: fire, earth, water, and wind. For example, a rabbit was composed of more water than earth because of its fluffy nature. Aristotle's theory was much more popular, as Aristotle was a widely influential philosopher, and it was much easier for the public to grasp Aristotle's theory rather than Democritus's abstract theory. And for the next 2,000 years, the atomic theory was never heard of. Till 1803, where John Dalton resurrected the idea of the atom. It was a rainy and foggy day, and he saw that the fog took up the same amount of space as the air. This got him interested, and after some research, he came up with a few principles. His first was that all matter was composed of indivisible particles. His second is that all atoms of one element are the same, and atoms of a different element are different. His third was that chemical reactions involve the combination of atoms and not the destruction. And lastly, his fourth principle, which stated that atoms react in fixed whole number ratios. We now know that his first two principles are false, because an atom is not indivisible, and atoms of the same element can be different because of isotopes. The next person to contribute to the atomic model was Thomson. In 1897, he discovered the first subatomic particle. He figured this out by emitting a cathode ray in a Crookes tube, to which he then put an electromagnet near, which caused the ray to bend. He concluded that there must be a negatively charged particle, and to balance it out, there must also be an equal amount of positively charged particles. He called the negatively charged particle the electron. His atomic model somewhat resembled the famous dessert plum pudding, with the pieces of plum being the electron and the dough being the proton. But then, in 1911, a stunning discovery was made by Ernest Rutherford. This discovery further proved his right to the Nobel Prize he won back in 1908. He discovered the nucleus. He discovered this by doing the famous gold foil experiment. So, to go into this experiment in detail, he first set up an alpha particle detector. In front of the barrier was a 1 atom thick gold sheet. At the gold sheet, he shot alpha particles. When he did, 99% of the particles went straight through the gold, hitting the detector on the other side. But occasionally, there would be one particle that would rebound back at a much stronger force. From this, he concluded that most of the atom must be empty space, and that there must be a concentrated center which consists of a positive charge. Another breakthrough discovery was made in 1913 that greatly contributed to the atomic theory. Niels Bohr was just messing around as he passed an electric current through a tube of hydrogen gas. This caused it to light up. When this light passed through a prism, 4 narrow bands of light were observed. So what did this mean to him? Well, we have to go inside the hydrogen atom first. Inside the atom, he hypothesized that there were different energy levels that electrons can exist in. The closer you are to the nucleus, the less energy. The further out, the more energy. So once a hydrogen atom was charged, an electron moves up an energy level because of its newfound energy, but it soon finds itself unstable. Because it's unstable, the electron goes back down a level and releases energy in the form of light. So now we understand that because the electrons move down while releasing light, they have different wavelengths, hence different colors. In 1932, Chadwick discovered the neutron. Very similar to Rutherford, he bombarded beryllium with alpha particles, to which in response, beryllium became radioactive. He observed that the particle emitted had a mass similar to the proton, but had no charge. He concluded that it was indeed another subatomic particle and called it the neutron. We now finally come to our present-day atomic model, which is credited to Erwin Schrödinger. He realized there was a problem in Bohr's model, as it only worked for hydrogen, and came up with his own. He said that electrons exist in 3D orbitals. There are 4 types of 3D orbitals an electron can exist in, and they follow a specific order of arrangement depending on the number of electrons present in the atom. This order can be seen in this diagram of the Aufbau principle. As you can see, we have come quite far from believing everything was made out of fire. But maybe in the next 100 years, our view on atomic theory will change.